One of the first steps as a penetration tester or as a hacker or whatever, when you're looking at a network or as a network admin, is to find out what in the world is on my network. This is also how you monitor your network to see what's going on. Or one of the ways you can monitor your network to see what's going on is use Nmap. And we can use Nmap. From the command line, it gives us lots of options. The advantage of that is we can pipe the results to a file. Some people like command line's versions better. So we always, Nmap is already installed, so we don't have to do any updates, even though I have it in the directions. It's just a good idea to update things. We want to make sure that you're actually on a real network. So if you go in your machine to settings, to network, we want to make sure we're on a bridged adapter. And that this is connected to your actual adapter that's connected to your network. If you do have to change this, you may have to shut down and restart your Kali Linux. If you're on a laptop with wireless, it's a good idea to make sure that you're up to the latest VirtualBox. I've discovered that the latest VirtualBox is a lot better at connecting to the wireless than previous versions. All right, well, let's zoom in a little bit. Whoops, wrong zoom. There we go. So you can see better what's going on. I'm just going to demonstrate these and talk about them. So IPA. Well, there's our Ethernet 0. Linux starts numbering things at 0. Windows numbers things at starting at 1. Who knows? This is, all right, there it is. This is my network address. And this is my particular host address. So 192.168.9.135 in a standard network means that my network is a couple different ways I can designate the network. So let me do an Nmap. And we're going to do what's called a ping sweep. In ethical hacking next semester, we actually write programs in Python, one that can use Nmap. And we also write a ping sweep and some scanners and support scanners, partly because it's fun, partly because it's useful, partly because it helps you understand how networks work. So what's my network address? Got to press my numlock. 192.168.9. Now what do I do? I can do this. 1 is my first address, dash 254 is my last address. That's one way to designate all 254 hosts on my network that I'm going to scan. Another way is 0/24. Left my slash out there. That also designates my network. And then it's going to do a scan. A ping sweep is very quick. Notice how quick it is. I don't have a lot on my network. Make sure also that when you are scanning networks, don't scan somebody else's network. Scan your network or scan D1. Well, you can see I've got lots of things on my network. There's my server. That's probably my Alexa. There's my irrigation system. I think that's my thermostat. I have a Netgear switch. So whenever I do scans, I've about memorized that I have about 14 devices. All right. And according to my directions, you have to use sudo. Well, apparently not anymore. Or when I wrote the directions, I was being paranoid. So I'm going to take that out because Nmap worked just fine with that. How many hosts are there? What other information is available? Well, a ping scan just means that I'm sending a ping to each host that's possible on the network. So a separate ping packet or multiple ping packets were sent to each host, 1 through 254. Well, that only gives us a certain amount of information. We may want more information as we're scanning the network. Well, for those of you who've been through Networking Essentials, This may or may not look familiar. It's just another picture that I found of the three-way handshake. Oh, there it is. Does a three-way handshake. That's what it's called, three-way handshake. So the client sends a synchronization packet saying, this is my number. So it might say, my sequence number is 1. The server says, I see your sequence number, and I'm going to add 1 to it and send it back as an acknowledgement that I received your sequence number. Plus, I'm going to send my own unique sequence number. So it sends that back to you, and you say, oh, okay, well, I'm going to add 1 onto here, send you back an acknowledgement that you received my sequence number, and that I received your sequence number, plus I'm going to add 1 more to my sequence number. So that handshake happens every time we're going to actually do something like, well, right now I had it. Nope. This, let's see, screencast does not do things over the internet. Okay. So if I'm going to Blackboard, for example, when my computer connects, it does this three-way handshake to make sure that we're copacetic and we can get together. The sequence numbers are because we slice packets up into little pieces. So if we have a big long file, they get sliced up into packets. This might be 1, 2, 3, 4. Well, these get set separately, and they might get set in separate routes, but when they arrive somewhere, they get reassembled based on these sequence numbers. That's what sequence numbers are for. All right, so this handshake happens every time you try to connect to a port. Well, a port is the location in the network on the computer that you're getting to. That's layer 4. Layer 4 is the transport layer. So we have an IP address, but to finally actually access a service, I should say service port, and the port is open. The port is open, meaning that the server is responding to the client. So guess how many times you do this during the day? Millions of times. Every time you connect to anything except video conferencing, streaming Netflix, YouTube, anything that doesn't require making sure that the data got there. Whenever you're doing TCP connections, we want to make sure the data gets there. I'm ordering something from Amazon and it's $100. I don't want to accidentally end up spending $1,000 for a $100 item. So this is for connection oriented. So send, act, the port is open. At the end, we say, oh, I'm done. And this guy says, yep, I acknowledge. I'm going to resend a reset. And we're done. So we are going to do port scanning. Let's see what ports are open. Now, I'm not in D1, but I have a server. You could also pick another computer. You could pick your router, which is your default gateway. You can pick whatever you want. So instead of typing everything all over again, I'm going to just cursor up and I'll scan my server, which is similar to the server it's a Windows Server 2022. I think we have 2016 yet in D1. So this is pretty close. So I'm doing Nmap -P. Well, what do you suppose -P means? Port scan. So we do this and it says, oh, my port specification. Oh, that's because I did not specify a port. Ha, ha, ha. I have to specify the ports I'm going to scan. I will do to 124. This is the range of what are called common ports. So there should be something. Oh, look at there. There is. Now, what do all these things mean? Well, I just know what some of them mean. This is DNS on port 53. NetBIOS is an old method that's still around for making name resolution, which is the older method, a Microsoft proprietary method of DNS. What else do we have? LDAP is our Active Directory communication. Active Directory uses this to confirm I am who I say I am. So we have a bunch of ports that are open. So what do these ports tell us? Well, for me, looking at this, I can determine that probably this is a domain controller of some sort. Does the report say that? No, not necessarily, but that's what it is. It's a domain controller of some sort, running probably Active Directory, Windows Server. So, let's see. Now the next one is to scan for all the open ports. Well, Nmap is multi-threaded, so it actually goes pretty fast. So we do -p, we take out this little list, and we go, and it may scan for a while. So I don't think I'm going to let it scan completely because it can take a while. So you might want to take a break, have a cup of coffee, maybe have a snack, and eventually when you come back, this will be done because this is going, oh, this is just scanning all the ports in my server. It may take a while because there's bunches of them. There's like 65,000 possibilities. So I'm going to stop that. All right, so now I'm going to scan. Well, do you have permission to scan D1? Yes. It says run this command. This is a vulnerability scan. So we're doing nmap --script equals vuln. It's a little scripting guy that's inside of our Mr. Friend, Mr. Nmap, wncc.net. And let's see, -vv, probably, oh, I have the wrong script here, don't I? All right, let's run it and see if things come up that are vulnerable in my little web server sitting in D1. Okay, so I don't know how long that's going to take. So if you get impatient to know what's going on, I was getting impatient. So I pressed the enter key and I discovered that, oh, it's telling me about how much it's done and how much time has elapsed and that it's not quite done. And it says it has 3 seconds remaining. However, it still has, now it has 4 seconds remaining. So I'm not sure it's really getting much done. So I'm going to pause again and wait and see what we get. I noticed that I left off -vv at the end of my command as I was typing it in. That gives us more verbal feedback as to what's going on. Well, there aren't any, apparently, there's nothing really wrong with my server. It says potentially interesting. There was no WordPress server. Well, that's true because it's a internet information server. So this is just the things it was looking for. Couldn't find anything bad, which that's good. So when you're doing scanning and penetration testing on your own network, this is typically the result that you want, that there's nothing going on. We can also do, besides just scanning for vulnerabilities, we can do what's called a brute force. -brute. And you'll want to run this against your local firewall to see if you can do anything with it. So mine's 192.168.1.1. Yes, it's your default gateway or firewall. So we're going to see if we can brute force a password against that. Notice I did not put this on each side. That's just to indicate that's a place marker for your IP address. So you go ahead and press enter and see what happens. It's got 4 ports open. Says there's really nothing that we can do. There's no way to get to anything on my firewall, so that's pretty good. And then you're going to run the same script against the D1 web server. The final one, which I'm not going to do the other one, is a trace route. So Nmap can do a trace route. And let's see, -p 80, and we are not penetration testing, we're running a trace route, so we can do that to wncc.edu without any trouble, because it's going to trace from here to there, and there it is. That's much faster than the trace route in Windows, but notice that it gives us each hop along the way from here to InMotion hosting, which is still hosting our our website. So this is also part of cybersecurity, is monitoring and keeping track. Oh, that's right. There's another one in here. Let's see what that one looks like. That's visitgreatbritain.com. I had a different one in here at one point, but it quit working. So I found this one in Britain, and it's actually hosted in Britain. Because I wanted to have it travel across the ocean through the, it's Visit Britain, not Visit Great Britain. There we go. It travels across the ocean, so the trace route's a little niftier. See, a few more hops, but it's coming back in. Well, maybe it's not actually going across the ocean. It could be, yep. It used to go across the ocean. Now they've got their stuff in what's called a content delivery network. So if you don't know what a content delivery network is, Google it. And that's it for today. Thank you.